Hi class. So this video goes over section 5.6, which is titled simulating probability experiments, right? So this section is just, using technology where we can simulate some experiments that happen, and we can gain some, empirical or experimental probabilities that way, right? So there's not really any new material. It's just maybe being familiar with how to use StatCrunch in order to get the answers that we need. So there's only 5 homework problems in this section, so I'm going to go through a few of them so that way you know how to use StatCrunch, right? So the first one I want to do is an interesting problem. So it's called the birthday problem. So the problem deals with determining the likelihood that at least 2 people share the same birthday in a room of n individuals. So it says open the data file which represents simulated birthdays of 15 individuals 2,000 times. Each birthday was assigned a number from 1 to 365, right? So the number is, that represents the day of the year, right? Complete parts A through C, right? So we're clicking on this icon, and there's multiple data sets, so you want to pay attention to which one it tells you to use. So this one, my problem happens to tell me to use dataset 1B. So if I click on that, it'll open it up into StatCrunch, right? So it says, what's the birth date of the randomly selected individual in row 5, column 5, right? So I'd go back to my table. We're looking for column 5, row 5. So that would be this value here, right? 271. Right, so it says, did the first simulation result in at least 2 people sharing the same birth date? So if we go back to the data set, notice this same birthday is like split up into 2 columns, but it still works. So if it says no and then match, that means, in other words, if there's a no in this column, it means there were not 2 birthdays the same out of 15 people, and if it says match, then that means that there is, right? So looking at the first simulation, the first row, there's no match, right? So we would say no. And then part B says, based on the simulation, what's the probability that at least 2 people will share the same birth date, right? So to do this, we can get a frequency table. So we go to stat, tables, frequency, and we want to do that for the same column. And I'm going to leave it with frequency and relative frequency, hit compute. So then the idea is, so we were looking at the probability that they do have the same birthday, right? That they will share the same birthday. So we would want the match column, right? So that relative frequency would be the probability, right? So 0.266. Right. So then now we're doing another simulation. It tells you step by step, and you can click on these pictures for screenshots to help you if if you need that. So I'm going to go over here. I'm just going to make a new data table. So the directions say to go to applets and then simulation and then birthday problem. And then it tells me to put 50 in for the number of students and to leave the common birthdays to greater than or equal to 1. And then we're using a fixed seed of 1126, right? So I need to fill that in. It tells me to hit compute. And then it tells me to hit 1,000 classes 3 times, so that way we're doing 3,000 runs, right? So I hit that once, twice, 3 times. And then the answer I'm looking for is, what is the proportion of samples that result in at least 1 common birthday, right? So that would be this value here in the table, this proportion. So I just need to type that in. Right, 0.2643 is what I had, and I got it. Right, now I'm moving on to the next question. right? All right, so the next problem that I wanted to do is question 4. It says the data in the accompanying table represent the outcome from simulating rolling an 8-sided die and a 6-sided die 500 times. Part A is to compute the sum of the dice for each of the 500 rules. What's the sum of the first rule? So if you click on this link, it'll pull up the data table, and then we want to input a new variable here where it's calculating the sum. So if I go to data, compute, and then expression, and then you click build, then what I want to do is take the 8-sided column and hit plus, and then the 6-sided column and hit add column, and then hit OK, hit compute. And then so what's happened here is we have, each of these numbers now are the sum of the 2 dice, right? So like this number is 5 plus 4, which is 9. It did that all the way down for me, right? So what I'm looking to do is it's asked, what's the sum on the first rule, right? So the first rule is 3 plus 5, which is 8, right? So I would click this here, 8. Part B says for each roll, determine whether the sum of the dice is greater than or equal to 10. Estimate the probability of rolling a 10 or higher from the simulated data, right? So something I can do here is I can go to data and then go to Ben, and then I'm going to click use cut points, and we want to use 10 as my cutoff point. And if I hit compute, oops, I got to click the column. So we wanted the 8-sided plus a 6-sided. Hit compute, and then so now what it's done is it's identified if the sum is below 10 or above, right? So we're looking for the probability of 10 or above. So if I go to stat now and then tables and then frequency, I want to do this Ben 8-sided plus 6-sided variable, hit compute. So then the probability of 10 or above would be this relative frequency, 0.306. I think it was 306, right? Yep. Right. So then, it says, why is the estimate using 500 simulated rules likely better, right? So why would using 500 rules be better than using 20 rules, right? Well, that's because of the law of large numbers, right? Hopefully you don't forget that law, right? The idea is the more trials we do, the closer it's going to get to the true theoretical probability, right? So we want the n value to be large, right? So doing it 500 times is much better than just doing it 20 times, right? And actually, in the previous question, I didn't do this. You can do it. I just showed you enough that you could do this in StatCrunch too now. But the sum, you do this for 20 rules, right?